my name is Chantel, and for this video, I'm going to be going over Active-HDL's block diagram editor. It's one of the graphical design entry tools Active-HDL provides alongside the state diagram editor. And with Active-HDL's block diagram editor, you can mix different types of descriptions into one block diagram design. And from there, the editor will automatically convert the diagram into a structural HDL netlist. So for this video, I'm going to be using the frequency meter sample design, and you could find this by going to Help, Open Example, and go to VHDL Designs. In this sample design, we already have some source files that provide behavioral descriptions of the overall design. And for this video, I've removed some components from the frequency top block diagram to demonstrate how to add those components in. When you want to make a new block diagram, just add a new file to your current design and select the block diagram option. You can use the wizard as well, and you'll just need to follow the wizard's instructions. Now for the block diagram editor, in this editor window are some toolbars. This left toolbar is the block diagram edit toolbar, and the right one is the diagram items toolbar, which has buttons for the components you can add into your diagram. You can even add auxiliary shapes and text too. And you can also find all these options in the diagram menu. And if you have a large block diagram with many pieces in it, you can go to the Objects View window. Here you can find all the block diagram items categorized, making it easier to find the item you're looking for. And to display connections for diagram items currently selected in the Active BDE window, go to the Query window. Now going back to the frequency top block diagram, one of the components I'll be adding first is the terminals. Click on this icon to select the terminal of your choice. You can choose single wire or bus terminals. Then just click inside the diagram to add it in. I'll add the rest of the terminals now. One more input and one bus output terminal. Hit Escape when finished, and you can use Escape to leave any block diagram editing modes. Then to edit the names of the terminals, just double-click inside the symbol to edit its properties. I'm going to name these terminals Reset, Start, and LED-A. Next, I'll be adding another symbol for the missing Hex 2 LED. Notice that we do have an already compiled source file for Hex 2 LED. In the Symbols toolbox, you can access built-in primitives or these HDL symbols that come from existing design libraries, and just drag them into the block diagrams. The count.bcd file uses the built-in symbols for AND gates, and for our frequency top block diagram, we can add another instantiation of Hex 2 LED. Now we can add some connections. For wires, you can click on the wire symbol or press W on the keyboard. Click for the starting point, then move and click around to anchor. And buses are similar to wires, just click on the bus symbol or press B on the keyboard. To name a wire or bus, just click on a part of the connection and right-click to go to its properties. There you can change the name and give it the option to show the name of the wire or bus. If you don't label it, a name will automatically be assigned based on its internal net number. If you have a design where multiple blocks share the same terminals, you can add a global connector to your diagram for better readability. In the count.bcd diagram, there's a global wire for the clock and reset of the inputs since all the instances of the counter share those same two inputs. To add a global connector for a wire or bus, just click on this icon and select which connector to use and add it to the diagram. Just be sure the terminal for the signal is in the design too. As a little side note, you can connect wires to buses to create bus taps. Just connect a wire to a bus and be sure to label the bus taps appropriately relative to the bus label and size. If your block diagram needs additional HDL statements, You can click on this icon here to add HDL statements like the unit header, generics or parameters, and more. Here we can see that signal assignments were used in count BCD2 instead of the AND gate symbols. In block diagrams, instead of symbols, you can also use processes or always blocks to perform the same function. In count BCD2, it uses processes to perform the same task as the count 4B symbols inside count BCD. Now for the last piece of the frequency top diagram, I'll need to add a FUB for the control unit, or a functional user block for short. To add one, just click on the FUB icon and then click and drag to adjust its size and release to finalize its creation. Then I'll add some pin connections to it from F pattern, reset, and start. And since FUBs are created prior to defining its contents, I'll now need to add its implementation. This FUB will be using the control.asf file that's been provided. So to do this, just double-click on the FUB to edit its implementation. I'm going to select State Diagram, and I'll locate the file for it. Then I'll name it Control, and once I hit OK, my control FUB is now fully implemented. I'll now right-click and use Add Stubs to create my connections, and I'll connect my controls output to the inputs of the count BCD block. I'll also be changing the instantiation name to U0 and make my control all caps by double-clicking on them. If you want to edit a symbol's shape or placement of pin connections, right-click and click Edit. I'm going to change the placement of the bus and wire pins here for the counters to get rid of that crossover look. And now that we have completed our top block diagram, we can now generate its code and compile it. You can adjust generation settings by going to Code Generation Settings in the Diagram menu, but since my settings are good, I can now click on Generate HDL Code. After code generation was successful, we can see the HDL netlist that was created. I'm going to make sure the design is working by compiling it. I made sure to have debugging enabled too. After successful compilation, I can now simulate with a test bench. When you're making your own test bench, you can use the block diagram editor to create one. But I'll be initializing simulation using this test bench configuration file. And now the cool thing about Active-HDL is that it has cross-probing capabilities during simulation. So in the top block diagram, I'm going to click on Synchronize with Waveform, and a new waveform window will pop up underneath. I'll get the signals from the frequency top design, and now we can run through simulation. I'm going to run for every 2 microseconds. And as I'm running through the simulation, the values on the block diagram and the waveform view update simultaneously. And with that, this marks the end of the video. I hope you all found this helpful, and thank you all for watching.